Hi guys, welcome to another video. Today we'll be doing roots of polynomial, which is on core pure maths, the further maths module. So as usual, here's a prior knowledge checklist for you guys to practice. So you could pause the video and have a go at this. So here's the answer for question 1a, B, for question 2, question 3a, 3b, and 3c. So prior knowledge check is this sort of knowledge you need to have in order to continue this chapter. So we're looking at polynomials, roots of polynomials. You need to be in a position where you recognize some patterns involving the roots of quadratic equation. So the quadratic equation of the form ax squared plus bx plus c equal to 0, where x should be a member of a complex number. So in the past you would have done quadratic where x is a member of real number, and now we're saying x could be a member of a complex number. That's what the C, capital C with the line going through it. So the solutions of the form a plus bi, remember that the either part can be 0, so this includes real and imaginary numbers too. So we'll always either have two real roots, one repeated root, or two complex roots, which occur as a conjugate pair. So if we let the roots be equal to alpha and beta, we can find the relationship between the roots and the coefficients for any equation like the one above. So imagine the roots of the quadratic equation ax squared plus bx plus c are given by alpha and beta. We can therefore write the following relationship. So this quadratic would equal to a bracket x minus alpha, x minus beta, because we're saying alpha and beta are the roots. So for example, for this quadratic equation x squared plus 8x plus 12, the roots are minus 6 and minus 2. So if we use this format here, we will see that this can be written as x minus minus 6, x minus minus 2, which we know is just x plus 6, x plus 2. So for example, for the equation 2x squared minus 9x minus 5, the roots are minus half and 5. So if we use this format, we could write it like this: x minus minus half, x minus 5. So we see the 2 here. So we could write the 2 outside, give the 2 bracket, and we'll get that as a value. So if we multiply the brackets, you get this, right? And now, if you group the terms together and divide by a, then this can be simplified down to this format. And now you could see clearly here that b over a is actually minus alpha plus beta, and that minus b over a would be just alpha plus beta. So the sum of the roots is minus b over a. Now if we look at c over a, we could compare the constant and say c over a is the product of the two roots, alpha beta. So the product of the root is minus c over a. The roots of the quadratic equation 2x squared minus 5x minus 4 are alpha and beta. Without solving the equation, find the values of alpha plus beta, alpha beta, and 1 over alpha plus 1 over beta. So these are your typical exam style questions. And for part D, we want alpha squared plus beta squared. So let's look at this quadratic. 2x squared minus 5x minus 4. We summarize A, B, and C first. So A is 2, b is minus 5, and c is minus 4. Then we write out the relationship that you'll see. So we know alpha plus beta is minus b over a. So if you substitute in a and b, we will see that alpha plus beta is minus 5 over 2. Which when we simplify, we get alpha plus beta equal to 5 over 2. So now, alpha beta is equal to c over a. So if we substitute in a and c, we say alpha beta is minus 4 over 2. When you simplify, alpha beta equal minus 2. Sometimes you want to find a way to write the relationship so that it uses alpha plus beta and alpha beta, 1 over alpha plus 1 over beta. So if you give this a common denominator, as usually you'll do with normal fraction, you could write this as beta over alpha beta plus alpha over alpha beta. So here you just diagonally multiply to give the common denominator. Now if we group them, since we have a common denominator, we could say alpha plus beta all over alpha beta. But we know what alpha plus beta is and alpha beta is, so if we substitute that in, 5 over 2 over minus 2, and we simplify this, we get minus 5 over 4. Now, alpha squared plus beta squared. Well, if we rewrite using a squared bracket, we could write this as alpha plus beta squared minus 2 alpha beta. Because when you have alpha plus beta squared and you expand this, you get extra 2 alpha plus beta, hence we minus this 2 alpha plus beta. So if we substitute in the values, alpha plus beta is 5 over 2, 5 over 2 squared, minus 2 times alpha beta, which is minus 2. If we calculate, it gives us 41 over 4. So here, the roots of the quadratic equation are alpha equals minus 3 over 2 and beta equals 5 over 4. We've been asked to find the integers for values of a, b, and c. Sometimes it helps to rewrite the original equation slightly. So ax squared plus bx plus c equal to 0. If we divide by a, we get x squared plus b over ax plus c over a equal to 0. So in this question, you have to use the relationship backwards. So we know alpha plus beta is minus b over a. If we substitute these values in, alpha and beta, and we add the fraction, we see minus quarter is equal to minus b over a, which when we multiply, we simply get b over a equals to a quarter. So now alpha beta is c over a. So if we multiply minus 3 over 2 and 5 over 4, we get minus 15 over 8 equal to c over a. So now we can replace this in the rearranged equation below. So we substitute the values x squared plus quarter x minus 15 over 8 equal to 0. And now if you multiply everything by 8, we get 8x squared plus 2x minus 15 equal to 0. So here we see a is equal to 8, b equal to 2, and c equals to minus 15. So they ask for the values, and we have our a, b, c values. So here are a couple of questions for you guys to test your understanding. So pause the video and have a go at these two questions. Okay, so for part A, your alpha beta is 3 and alpha plus beta is -2. And for this part here, for part B, so we have our A equal to 15, B minus 13, and C equal to 2. We can follow a similar process as we did for the quadratic for cubic. So if a cubic equation ax cubed plus bx squared plus cx plus d equal to 0 has the roots alpha, beta, and gamma, then the following relationship can be written. We could write this cubic equal to a x minus alpha, x minus beta, x minus gamma. If we expand the bracket, be slightly careful here to do the quadratic first and then the quadratic by the linear. So we get the following. And if we group like terms and factorize, so when we group them, we could write x cubed minus x squared and alpha plus beta plus gamma, and then x, alpha beta, beta gamma, alpha gamma, minus alpha beta gamma. So now if we divide all by a, okay, it simplifies down to this. So now, if we compare the coefficient of x squared, b over a equal to minus alpha plus beta plus gamma, or minus b over a equal to alpha plus beta plus gamma. So the sum of the single root is minus b over a. Now if we compare the coefficient of x, we'll see if we compare the coefficient of x, we'll see c over a equal to alpha beta plus beta gamma plus alpha gamma. So the sum of the doubled roots is c over a. If we compare the constants, d over a equal to minus alpha beta gamma, the product of all three with a negative. So we could say minus d over a equal to alpha beta gamma. So the sum of the triple roots is d over a. Sorry, minus d over a. So comparing the patterns with quadratics and cubic. So for quadratic, alpha plus beta is minus b over a. Alpha beta is c over a. For cubic, alpha plus beta plus gamma is minus b over a. And alpha beta plus gamma beta plus alpha gamma is c over a. Alpha beta gamma equal to minus d over a. So sum of singles minus b over a. Sum of doubles c over a. And sum of triples minus d over a. So if alpha, beta, and gamma are the roots of this cubic equation, 2x cubed plus 3x squared minus 4x plus 2 equal to 0, we want to find the values of a, alpha plus beta plus gamma, b, alpha beta plus beta gamma plus alpha gamma, c, alpha beta gamma, and d, 1 over alpha plus 1 over beta plus 1 over gamma. So here's our cubic. We're going to summarize a, b, c, and d first. So a is 2, b is 3, c is minus 4, d equal to 2. Then write out the relationship that you will use. So alpha plus beta plus gamma is minus b over a. And my advice is every time you use this, write it down. The more you write down the general rule, will help you remember. So if we substitute in a and b, we see the sum of all three roots equal to minus 3 over 2. Now if we take the doubles, alpha beta plus beta gamma plus alpha gamma equals c over a. If we substitute in c and a, we get minus 4 over 2, which equals to minus 2. Now the product of all three roots equal to minus d over a. So if we substitute in d and a, we get minus 4 over 2, which equals to, or we should have said minus 2. So the typo here. So that slight error here, I shouldn't have said minus 4 over 2, should have said minus 2 over 2, which is minus 1. So the product of all three, alpha, beta, gamma, is actually indeed minus 1. So now for part D, we got the reciprocal of each of these roots. So we need to think about common denominator. So common denominator would be alpha, beta, gamma. So for the first one, I need to multiply by beta, gamma. Second one, we need to multiply by alpha, gamma. And the third fraction, I multiply by alpha, beta. And you have to do the same with the numerator. So now if you group them, we have a common denominator, alpha, beta, gamma. We could now replace using b and c, because we know what alpha beta plus beta gamma plus alpha gamma is, and alpha beta gamma is. So we go minus 2 over minus 1, which gives us 2. So the roots of the cubic equation, we're told alpha is equal to 1 minus 2y, beta equal to 1 plus 2y, and gamma equals to 2. Find the integer values for a, b, c, and d. So it can help to rewrite the original equation if you divide everything by a, just like what we did quadratic, and we could put it into this format here. So in this question, you have to use the relationships backwards. So we know the product of all three roots equal to minus b over a. So if we substitute in the roots and we simplify, we see we get 4 equal to minus b over a. Which when we simplify further, b over a equal to minus 4. So now if we look at the doubles of the root, we know that's equal to c over a. So we substitute in the roots and expand brackets. So if we simplify, c over a is equal to 9. Okay, so now the triple of the product is minus d over a. So if we replace this and expand, okay, so if we expand and simplify, we get d over a equal to minus 10. So now we've got all three. We could just substitute this into the relationship from above. So if we could just replace b over a with minus 4, c over a with 9, and d over a with minus 10. So we see the values of a, b, c, and d. A is 1, b is minus 4, c is 9, d is minus 10. Okay, so we're going to be looking at the roots of quartic equation. So quartic, your highest degree of polynomial will be x to the power of 4. And you could just call it ax to the 4 plus bx cubed plus x squared plus dx plus e. equal to 0. And here, because it's quartic, you could expect 4 roots. So we'll call it alpha, beta, gamma, and delta. So if the quartic equation has roots alpha, beta, gamma, and delta, then the following relationship can be written. So it's very similar to what we did with the cubic concept of cubic equation. So if we expand the brackets, you can see it's quite messy here because it's full lots of brackets to multiply. And if you guys want to do this, you could always use binomial expansion. And if you group them, and if you then look at the coefficient of x to the 4, x cubed, x squared, and x and the constant, and you divide it by a. Okay, so if you divide both sides by a, you will see that if you compare the coefficient of x cubed, it's b over a equal to minus plus the sum of all 4 roots. So we could write minus b over a equal to sum of all the roots. So the sum of the single roots is minus b over a. If you compare the coefficient of x squared, so c over a is equal to the following. So here we see a pattern, the sum of the double root is c over a. And if we compare the coefficient of x, that's d over a equal to minus sum of the triple. So if we just take the minus 1 and multiply on both sides, we could say the minus d over a is the sum of the triple roots. And if we compare the constant, so e over a, so sum of the quadruple roots is e over a. So if we compare the patterns between quadratics, cubics, and quartics, we could see this, and this was on the previous slides, the quadratic and quartic, quadratic and cubic. Now if you look at comparison with quartic, you get the following. So you can see the relationship here. It's very easy to remember because you all follow the same pattern. So we've got all the sum of singles, sum of doubles, sum of triples, and sum of quadruples. So here's a question. So we have an equation, x to the 4 plus 2x cubed plus px squared plus qx minus 6 equal to 0, where x is a member of complex number and p, q are member of real numbers, and we're told the roots are alpha, beta, gamma, and delta. Given that gamma is equal to minus 2 plus 4i and delta is equal to gamma squared. Now here, gamma star, which is the conjugate of the gamma. And we've been asked to show that alpha plus beta minus 2 is equal to 0, and that alpha beta plus 3 is equal to 0. B, hence find all the roots of the equation and the values of p and q. So we know the sum of the single roots is equal to minus b over a. So if we substitute the values, alpha plus beta plus gamma, which is this, and then plus delta, which is this. Remember here, delta, we were told, is conjugate of gamma. So it's just minus 4i. And that's equal to minus b over a, so minus 2 over 1. So if we calculate and simplify, we get alpha plus beta minus 4 is equal to minus 2. So if we work that out, you can see it's alpha plus beta minus 2 is equal to 0. And that's what it said, simply just show that. So we've shown it. Okay, so this is quadruple, so alpha, beta, gamma, delta is equal to E over A. So if you substitute in the value, because we know what gamma and delta is, just plug in the value and then calculate and simplify. Okay, so you do the calculation and you can see if you divide by 20, you get alpha beta equal to minus 3. So if you take that over, we could show that alpha beta plus 3 is indeed equal to 0. And this is hence find all the roots of the equation, the values of P and Q. So you can see part A is here to help you for part B, and the word hence is used, so make sure you use what we've got for part A. So alpha plus beta minus 2 is equal to 0, alpha beta plus 3 is equal to 0. So if you rearrange this, alpha is 2 minus beta, and alpha beta plus 3, you could replace your alpha with 2 minus beta. And from here, you can see it's a straight calculation. You multiply the bracket, get yourself a quadratic, and then you simply factorize this, and we get the beta value. So that means alpha would equal to minus 1, or alpha is equal to 3. Notice that we actually have two real roots here. So the roots are minus 2 plus 4i, minus 2 minus 4i, 3, and minus 1. Yep. So now we know from the sum of the double is equal to C over A. So if we substitute this information in, alpha beta, beta gamma, gamma alpha, and so on, you get this, which looks quite horrendous. But to cut the long story short, you could just write that as 9 is equal to P. Now guys, you are doing further maths, so you do expect some heavy calculation at certain times. And now for the sum of the triple, minus D over A, so we substitute this in, we have all of this, and same as before. To cut another long story short, minus 52 is equal to Q. So now we've got P equal to 9, Q equal to minus 52. So if we look at the rules for the sum of the reciprocals, so we've seen this first one previously on quadratic. So 1 over alpha plus 1 over beta is alpha plus beta over alpha beta, because we rearranged it and we solved the equation. And similarly with the cubic, if we have 1 over alpha plus 1 over beta plus 1 over gamma, then it's the sum of the doubles in the numerator divided by the product of all three of the denominator. And for quartic, the reciprocal of the quartic, it's the sum of the triple on the numerator and the product of the quadruple at the denominator. So you can see there's a pattern to this. So you have hopefully also encountered these in some questions so far. So these are specifically when the roots are of a quadratic. So if we have, let's say, alpha squared plus beta squared, then we know that alpha plus beta squared is minus 2 alpha beta. And for cubic, if we have alpha cubed plus beta cubed, it's alpha plus beta cubed minus 3 lots of alpha beta, and then times by sum of alpha beta. There are also equivalent roots for the roots of cubic and quartic equations. So if we expand this, okay, so we could write these as double brackets, and if we expand using FOIL and group like terms and refactorize these the latter part, so we have 2 lots of the sum of the doubles, we can find a relationship for the sum of squares of the roots. So if we rearrange this, you will see that the following: alpha squared plus beta squared plus gamma squared is equal to this, and alpha plus beta plus gamma all squared is equal to this. Okay, so a cubic equation has roots alpha, beta, and gamma, such that the sum of the doubles is equal to 7, and the sum of all three is equal to minus 3, and we're asked to find the values of alpha squared plus beta squared plus gamma squared. So we know that this can be written in this form by rearranging, as we seen earlier. So if we substitute the information, so we know alpha plus beta plus gamma is minus 3, so it will be minus 3 squared, and 2 lots of the 7. So if we calculate this, we get minus 5. So the rules for the sum of the squares, alpha squared plus beta squared, we've already looked at this. Now if we look at the cubic, we've also looked at this. Now for quartic, you could see this pattern to this. So alpha plus beta plus gamma plus delta squared minus 2 lots of the sum of the doubles here. So the rules for cubes, so alpha cubed plus beta cubed is alpha plus beta cubed minus 3 alpha beta, and then times by sum of the two roots, alpha plus beta. So for a cubic, it follows quite similar to this. So we have the sum alpha plus beta plus gamma all cubed minus 3 lots of this plus 3 alpha beta gamma. And we don't need to know the sum of the cubes of quartic, is not required, luckily. So we're okay. Okay, so here's a question. We're told the roots of the cubic equation are alpha, beta, gamma, and given that the product of all three is equal to 4, and the sum of the doubles is equal to minus 5, and the sum is equal to 3, we're asked to find the value of alpha plus 3, beta plus 3, gamma plus 3. So we're adding 3 to each of the roots. So if we expand the brackets, factorize some parts of it, so we get alpha, beta, gamma plus 3 lots of the sum of the double plus 9 lots of the sum of the single plus 27. And if we simply substitute the values, so we know the the product of all three is equal to 4, the sum of the doubles minus 5, and sum of the singles is 3. So if you just substitute that in and do the calculation, we get 43. Okay, so if you know the sums and products of roots of polynomial, it's possible to find the equation of second polynomial whose roots are linear transformation of the first. So for example, if the roots of a cubic equation are alpha, beta, and gamma, you need to be able to find the equation of the roots of, let's say, 2 more than the roots of all alpha, beta, gamma. So alpha plus 2, beta plus 2, gamma plus 2 for the equation of the roots 3 alpha, 3 beta, and 3 gamma. So let's say you have a cubic equation and you have the roots of this cubic equation to be alpha, beta, gamma. So what we're going to do is find out what would the equation be if the roots were doubled. So let's focus on the doubling of the roots. So 2 alpha, 2 beta, 2 gamma. And then also look at what would happen if you were to increase the roots by 3. So the first method is using the roots. So we calculate each value from the original equation. So we know that sum of the 3 roots is equal to minus b over a. So in this case, minus 2 over 1, minus 2 over minus 1, so that'll give you 2. And the sum of the doubles is equal to c over a, so in this case is equal to 3. And the sum of all, or the product of all 3 is minus d over a, which is equal to 4. So we can use this to find the new relationship between the roots. So 2 alpha plus 2 beta plus 2 gamma. So if we just factorize and take the 2 out, because we already know what the sum of the 3 roots are, we can simply substitute that in. So 2 times 2 we got 4. So there we have it. 2 alpha plus 2 beta plus 2 gamma equal to 4. So now let's look at the next bit here. So if I have 2 alpha, 2 beta, plus 2 beta, 2 gamma, 2 alpha and 2 gamma, and I multiply and factorize this, I'll get 4. And this is simply coming from this idea here. So you're replacing, the alpha with 2 alpha, beta with 2 beta, and so on. But you know what the sum of the doubles are, which is 3. So if you do 4 times 3, that gives you 12. So now, if we multiply 2 alpha, 2 beta, 2 gamma, we'll get the 8 and take the factor of 8 out. We could also write this as 8 times 4, because alpha, beta, gamma is 4. So that's equal to 32. So let's look at this cubic equation. If we divide the whole thing by a and replace the coefficient, this is minus b over a, this is c over a, and this is minus d over a, then we'll get the following equation. So a new letter is usually used to represent the new equation. So let's just say we'll call it w. So we could write this as w cubed minus 4w squared plus 12w minus 30. Okay, so now let's look at the method 2 using a substitution. So imagine we knew the roots were. So this is a function, the original function f of x. What transformation would cause the roots to double? So In this case, if we're going to double this, we're looking at going from -2 and 6. So the function is going to be f half x. Remember, what's inside the bracket is usually the opposite. So if you have x minus 1, you actually go to the right by 1. If you have half x inside, then you're actually doubling it. We can find the transformation needed by using letter w and thinking about what happens to the roots. So if we let w equal to 2x and divide by 2, so x is equal to w over 2. So in the original equation, you need to replace x with w over 2. So start by considering how the roots should change. In this case, the roots needs to be doubled. So if we divide by 2, so x equals to w over 2, we can now substitute this into the original equation. So we get the following. Now if we just multiply the brackets and multiply by the highest denominator, which is 8, so we don't have any denominators here, so we get the following. You will usually find that substitution method is easier. So start by considering how the roots should change. In this case, the roots need to increase by 3 for part B. So we could let w equal to x plus 3. So if we make x the subject, w minus 3, and we substitute into the original equation. So if we replace the x with w minus 3, we multiply the bracket, and there's a cubic here, so it's a little bit of length in terms of multiplying out. If we multiply and simplify, we get the following. So using the substitution method, we know it's increasing, it's doubling and then increasing by 1. So w equals 2x plus 1. So if you then make x the subject, so w minus 1 all over 2. So once we substitute that in, it's a Quartic equation. So we know it's going to be a little bit messy, but you could always use the binomial expansion method, and you could use a graphical calculator or scientific calculator to help you in this case. So here, if we multiply all of this by 16, we get the following. And if you expand and group the like terms, we get a Quartic equation.